Solve the following system of equations by using a matrix. Here we have a 3 by 3 system. There's 3 variables and 3 equations. So this is considered a large system. And in order to solve large systems, you can use elimination and substitution methods, but really the Gauss-Jordan method is designed for large systems because it's easy to get lost in the process. So to get started, what we do is we express this as an augmented matrix, which means we just take the coefficients of the system and put it into a matrix. That matrix coefficients would be 3, 2, -2, and then we do a bar for the equals, and then another -2, 1, -3, 4, -13, then -2, 5, 6, and 29. So all I'm doing is taking the variables from the x's and basically making an x column in this matrix, and then a y column, a z column, and a column for the constants. Now, there is a process that would allow us to solve this algebraically, but the calculator is what we're going to do here in order to find the answer. So in order to use the calculator, what we need to do first is pull it up, obviously, and enter the matrix into the calculator. So if you look above the x to the -1 key, that's the matrix menu. So if you hit second and the x to the -1, that will take you into the matrix menu. And you're able to edit matrices if you slide over to the edit submenu, and all of the matrices you have available to you, you can freely edit. I'm just going to pick matrix A here. I need to define the size, and the size goes rows by columns. So rows here I have 3, and columns I have 4. So I just need to change this to a 4, and it will adjust my matrix. All right, now I'm going to enter the coefficients of the matrix in, and just make sure you're careful that you typed those in correctly, because that's really the only place that you could make a mistake in getting an incorrect answer here. So that is -2, okay, and 5, 6, and 29. Okay, now that that's in, I'm going to move this over and make a larger screen so it's easier for you to see. All right, so that matrix has been entered, and the next thing that I will do is quit out of the matrix editor, then press second and next to the -1 to go into the matrix menu again. But this time I go into the math menu because I want to do an operation, and just keep scrolling down until you see one that says RREF. That stands for row reduced echelon form. That is different from REF, which is just reduced echelon form. So we'll just make sure we select RREF. And then we need to say which matrix we're working with. So if I hit second and matrix, the first one here that I entered was matrix A. So I'll just select the name and press enter. Then close parentheses. And when I hit enter, it will run the program and solve the matrix. And it outputs the answer in this form. And I'll copy that down back over here. So that's going to be 1, 0, 0, 0, 1, 0, and 0, 0, 1. And we had -3, 4, and 0.5. Okay, so because this first column is still the x column, the second is the y column, and the third is the z column, and then it's equal to constants. If I change this back into a system of equations, then it would look like 1 times x equals -3, so x equals -3. 1 times y equals 4, so that's just y equals 4. And then 1 times z equals 0.5, so z equals, I'll go ahead and change that to 1/2. And this right here is the definition of a solution. because the solution is going to be a coordinate pair for all three variables, x, y, and z, that solves this system. And so these are the values that if I plug back into the system would satisfy all three equations at the same time.